Hello. Today I'm going to talk about a problem from chapter 4, application of derivatives. Now, what I'm going to show you today are two parts for the application of derivatives. The first one is identified as increasing, decreasing functions. And the second one, if that gets success, we will find possible relative minima and maxima from the function. Okay, so let's get started. If f is a continuous function on a closed interval a comma b, so that's first part, f of x is continuous. This is very important for you to start with a continuous definition on a closed interval a comma b. Then we'll do two problems from there. Number one, find where the function increases and decreases. Okay, so there is a test for this increasing and decreasing function test for this part A. If derivative of the function is positive, which is greater than 0, f is increasing. On this closed interval a comma b. Part 2, if f prime of x is less than 0, then the function is decreasing on a comma b. Okay, so with these two, let's go do an example problem. A polynomial function is a good example, so I'm putting up f of x is 2x cubed plus 3x squared minus 12x. Okay, so first thing we need to do is take the derivative of the function and see if there are critical numbers and what they are. So taking the derivative of the function will be 6x squared plus 6x minus 12. Okay, now we are going to put it in equal to 0 to solve for x. Will give us the critical numbers. So from here, we can factor it and simplify further. So it's going to be factoring 6 out. It will be x squared plus x minus 2 equal to 0. And that will give us one more. Take this 6 out of the way. So these are the two factors now, which will be x plus 2 and x minus 1. From here, we should be able to find the critical numbers. Will be x equal to minus 2 and plus 1. Okay, so this is the first thing we must do for the increasing decreasing function test. Okay, so now I'm going to erase this part and start a table for this test. So it's going to be a long table kind of, so but we will hang in there and do the best we can. Let's say interval. It's a sensitive board, so sometimes it messes up. Intervals are coming from that critical numbers that we just calculated earlier. Then we have test values. Then we'll be testing for sign of the first derivative, which is f prime of x, and that will give us a conclusion for this increasing decreasing function. Okay, now we'll have to have, I know that critical values were found earlier, CNs where x equal to -2 and 1. Okay, so intervals will be coming in between. So we have intervals starting, and this is a polynomial function, so we're going to have it from negative infinity to negative 2. You can put in this form, or you can put in a inequality form. It's up to you, but let's just put it this way. Then we have between is -2, 1 is another part of the interval. Then we have 1 to infinity. Okay, so these are the entire number line, and including those two critical values. Now the test value could be chosen anything in between these. So I'm choosing x equal to, say, -3 here. Between these two, I am choosing 0 is always a good number to my opinion, because it makes it calculation quicker and easier. Then I'm choosing x equal to 2 for the last one. These are my test values. Okay, so let's also put up on the top what was my derivative that I used earlier. F prime of x is x squared plus x minus 2. Okay, so having that, if I am choosing this test value here, f prime of -3 is going to be calculated from this is a 4, and this will be identified as a positive value. So let's put it greater than 0 here. And so then the next thing is f prime of 0, which is going to be -2, and that's less than 0.
Don't you have a 6 on the top? 6 on the top.
And then we have f prime of 2 is gonna be 4, which is positive. Okay, perfect. Now this is gonna work really well for a successful testing on increasing and decreasing function. So when we talk about that, we also, I did tell you earlier about positive means increasing. So this will give me increasing. So I just say increase. Then this is negative. That means this part of the function is decreasing here. And then again another positive means another increase of the function here for the graph. Okay, so now we have completed the table as shown here. With that said, now my first part is where it is increasing, decreasing. We have now, this is a conclusion. So in this interval, graph of the function is increasing. In this interval, the graph of the function is decreasing. And in this interval, the graph of the function is increasing once again. So this is going to go up and down kind of curve, is smooth and continuous because the function is continuous. Okay, so that's the first start and first finding of these application of derivatives in here. The second part will come really close to this finding in here. So let's say we are trying to find part B. I'm going to put it up here because I need that space down there. Find any relative max and or minimum if the graph has any. Okay, so with that said, we must also know what is relative max and minima means in here. And this is a kind of long definition there, but let's see what I can do about this. Part A, if f prime of x changes from positive to negative, let's put it shortly, positive to negative, plus to minus, okay? Then it has a relative max, has a relative max. This is one of this definition here in part B the same way. If f prime of x now changes from negative, now it's negative to positive, okay, then has a relative minimum. So this is what we are going to do it, and this table will identify that two relative minimum maxima finding if there are any. Okay, so with all that said, let's say positive to negative is increasing to decreasing, so I'm going to point it out from here. These two together will identify in this interval a relative max, which is this one. Now, negative to positive means this one, which is decreasing to increasing. And now we will identify this from here, and the function graph is going to have a relative minima from the interval shown on the top like this. So that pretty much gives us the finding of maxima and minima here. And in order to identify their exact location where this graph has a maximum and where it has a minimum, we are going to take into this critical value. That's why it's going to be, so when x is negative 2, we will be calculating the value from the original function that was given in the previous page. So f of negative 2 will be calculated as a 20, which means the maximum is located at negative 2 to 20. And then f of the other critical value is a 1. F of 1 is going to be a negative 7, which means the minimum is located at 1 comma negative 7. And this is the exact location. If you graph it, then you will see there is a maximum at this point and there is a minimum at this point. And that's the major part of the application of derivatives from chapter 4.